Of course, if we don't restrict the domain to a particular set of angles, there are actually an infinite number of possible solutions to any given trig equation. Well, to most trig equations anyway. For example, the equation sin x equals a half is going to give me the solution 30 degrees, pi on 6. But we're talking about sine, so there's another answer over here as well in the second quadrant. However, there's actually many more, because what I can do is I can go around and around this circle again and again and again. Over here I'll be going 0 plus pi on 6, 2 pi plus pi on 6, 4 pi plus pi on 6, 6 pi, and so on and so forth. Now here's a few of them here. Over here I'm going to be going pi minus pi on 6, 3 pi, because that's pi plus 2 pi, 3 pi minus pi on 6, 5 pi minus pi on 6, and so on. There are many, many solutions. In fact, don't forget you can also go into negatives. Minus pi minus pi on 6, minus 2 pi plus pi on 6, and so on. It would be nice if we could describe this general solution without having to write every single one out. And of course we can. So the general solution for a sine graph, for example, is going to give you your first quadrant angle, plus any number of 2 pi's. 2n pi means an even number of pi's plus my reference angle. But it could also be an odd number of pi's, 2n plus 1 pi, minus my reference angle. For any number of multiples, integer multiples, n. Actually, we can be even cleverer. We can write this in one statement. It's n pi, 0, 1, 2 or 3, plus or minus that reference angle. But it's plus the reference angle when it's an even number and minus the reference angle when it's an odd number. How do I get a number that's plus when it's even and minus when it's odd? Well, here's the common trick we use. -1 to the power of n. If n's an integer, here's what happens. If n is 0, -1 to the power of 0 is +1. So it just gives me the reference angle. But if n is 1, it's going to be -1, so it's negative the reference angle, and it gets subtracted. If n is 2, we're back to positive, so we go plus. If n is 3, we're back to negative, so we go minus, and so on. So this is the trick we use to make that happen. So anytime you have a sine, you're going to get a general solution that looks something like this. We can do the same trick with the others as well. For example, what about cos? Now, we're looking at the same reference angle, so you can see exactly what's happening. If cos is √3 on 2, then I've got a reference angle of 30 degrees, or pi on 6. Cos could be here in the first quadrant, or here. Let me move that up a little bit. Right. So it could be here in the first, or here in the fourth. So it's always an even multiple of pi, or 360 degrees, plus or minus that reference angle. So we could step them out one at a time, or we can actually write a general form, like before. The general solution for cos is going to look like this. An even multiple of pi, plus or minus the reference angle. And tan is exactly the same. But tan, you should, I hope, remember, tan repeats every 180 degrees, or every pi radians. So the general solution for tan is actually quite simple. It's some multiple of pi plus my reference angle. It's if this is my reference angle theta, then I can write my answer as any multiple of pi plus theta.